Okay, for this equation, we notice that the bases are the same. If the bases are the same, we can set the exponents to be equal to each other. So we have x minus 3 is equal to positive 6. We will then isolate for x by adding 3 to both sides. This will leave us with x is equal to positive 9. Let's go ahead and box our solution. Moving on to question number 2. For question number 2, we notice that the bases are not the same. The base on the left-hand side is a 25. The base on the right-hand side is 125. So we have to ask ourselves, what base can I use that both of them will be divisible by? Well, we're going to indicate that we will use 5 as the base. So 5 to the what power will give us 25? Well, 5 to the second power will give us 25. We then wrap that in parentheses, and we keep the original exponent, 2x plus 1 equals, then on the right-hand side, we have the same base that we just spoke about, 5, and we ask ourselves 5 to the what power will give us 125? Well, 5 to the third power will give us 125. We then write down the original exponent, x plus 2. And keep in mind that if you ever have an exponent outside the parentheses, you have to multiply. So we have 5 to the power of what? 2 times 2x will give us 4x. 2 times 1 will give us positive 2 equals 5 to the power of what? 3 times x is 3x. 3 times 2 gives us positive 6. So from there, we notice that the bases are the same. What can I do now? Well, I can set the exponents to be equal to each other. So I have 4x plus 2 is equal to 3x plus 6. Now, my recommendation when you're solving these types of equations is to always move the variables to the left-hand side and the constants to the right. So in this case scenario, I will subtract 3x on both sides. I will subtract 2 on both sides. And you can do this in separate steps, or you can do it all together just like I'm doing this right now, your choice. From there, in the bottom left, I have 4x minus 3x, which will leave me with x. The 2's cancel out, equals, we have 3x's cancel out, and we have 6 minus 2. 6 minus 2 is going to leave us with positive 4. So hence, the solution is going to be x equals positive 4. Moving on to question number 3. For question number 3, we have to simplify on the left-hand side. This will turn into 2 to the power of what? 3 times x will give us 3x equals, we then have the multiplication of two bases that are the same. So I will add the exponents. So this will turn into the single base of 2 to the power of 3 plus 2x. I will then set these two exponents equal to each other. So I have 3x is equal to 3 plus 2x. I will then move all the variables to the left-hand side and solve for x. So I do minus 2x minus 2x. On the left-hand side, 3x minus 2x is going to leave us with x equals, on the right-hand side, the 2x's cancel out, and I'm left with 3. So the solution is x equals 3. Moving on to question number 4. For question number 4, again, you always want to work with the smallest base that they give you. In this case scenario, 3 is the smallest base that they give me. So let's go ahead and try it out. On the left-hand side, we have the same thing, 3 to the power of 4x minus 9. On the right-hand side, we ask ourselves, 3 to the what power will give us 243. But also keep in mind that this is a fraction. So if it's a fraction, it has to be a negative exponent. Let's go back. So we have 3 to the what power will give us 243. Well, that would be 5. But because we have a fraction, we have the exponent of -5. Now that we have matching bases, I will then set the two exponents equal to each other. So I have 4x minus 9 is equal to -5. I will then isolate 4x by adding 9 on both sides. Plus 9, plus 9. This will leave me with 4x. The 9's cancel out. And I'm left with -5 plus 9, which is going to leave me with positive 4. I will then divide both sides by 4. And this will leave me with a final solution of x is equal to positive 1. Moving on to question number 5. For question number 5, we have the following. Keep in mind that on the left-hand side, we have a fraction. Now, again, you want to deal with the smallest base that you can see. In this case scenario, I am given a hint right here, 4, right? So I'm thinking to myself, yes, I have 1 over 4, but I'm asking myself 4 to the what power will give me the 1/4, the fraction, correct? So let's go ahead and investigate that. We have 4 to the power of 1 will give us 4, correct? But we have a fraction, so it's going to be -1. We wrap that in parentheses, and we write down the original exponent, x, equals, that we then ask ourselves 4 to the what power will give us 256. Well, it's going to be 4 to the 4th power. In this case scenario, I can then do what? Well, I can go ahead and simplify this on the left-hand side to get 4 to the power of -1x is equal to 4 to the power of 4. Now that I have the same matching base, I can set the two exponents equal to each other. So I have -x is equal to positive 4. I will then divide both sides by -1. And this will leave me with a final solution of x equals -4. Let's go ahead and box that in. Moving on to the next question, we have the following. Keep in mind that you are dealing with a fraction, so you need a negative exponent. And they do give you a hint. They're looking at 4, right? They give you a hint for what potentially could be the base. So let's go ahead and try out 4. You never know. It might work, it might not work, and we have to move on to 2. All right, so we have 4 to the what power gives us 1 over 4. Well, it's going to be 4 to the -1. Equals, we then have 16 to the power of x. Well, we can rewrite 16 to be what? 4 to the 2nd power. We wrap that in parentheses. We keep the original exponent, x, right there. And we then simplify on the left-hand side. We still have that 4 to the -1 equals on the right-hand side. We have 4 to the power of what? 2 times x gives us 2x. Now, looking at this, we have what? We have the same base, so we can set the two exponents equal to each other. So I have -1 is equal to 2x. We divide both sides by 2. And this will leave me with a final solution of -1/2. Moving on to the next question, we have the following. Now, for this one, again, you want to look at the smallest base that they give you, and you want to work around with that, okay? In this case, it's 7, and right, all of the terms right here, this base of 49 is divisible by 7, this 7 is divisible by 7, and we end up with a whole number. So let's go ahead and try it out. So we know that 7 to the first power is going to be the case scenario, so we don't have to write down 1, so it's just simply going to be 7 to the 6x minus 2 equals, we can replace 49 with 7 squared, wrap that in parentheses, write down the original 2x minus 5. We then simplify, this turns into 7 to the power of 6x minus 2 equals 7 to the power of what? 2 times 2x gives us 4x, 2 times -5 gives us -10. We then notice that the bases are the same, so we set the two exponents equal to each other. 6x minus 2 is equal to 4x minus 10. We then move all the variables to the left-hand side, all the constants to the right-hand side. So we have minus 4x, we have plus 2, we have plus 2. And again, keep in mind that you can do this individually in single steps, or you can do it all together in one single step, your choice. All right, so we have 6x minus 4x. That gives us positive 2x. The 2x's cancel out, equals the 4x's cancel out. Negative 10 plus 2 is going to leave us with negative 8. We then divide both sides by 2. And this is going to end up giving us a final solution of x is equal to negative 4. Let's go ahead and box that in. Moving on to the next question, we have the following. Now, again, you want to look for the smallest base, okay? And sometimes it works, sometimes it doesn't work. So let's go ahead and see. We have 2, we have 8. Well, I know that 2 to the power of 3 will give me 8. 2 to the power of 1 will give me 2. So I can do the base of 2. Let's go ahead and try that out. So we have 2 to the power of 3x minus 1. That remains the same, equals. We have 2 to the what power gives us 8? Well, 2 to the third power, but because it's a fraction, it's going to be 2 to the negative 3. We then wrap that in parentheses, and we keep the original exponent x right there, and we then simplify. So this will turn into what? 2 to the power of 3x minus 1 is equal to 2 to the power of what? Negative 3 times x. That gives us negative 3x. We have the same base, hence we can set the exponents equal to each other. I have 3x minus 1 is equal to negative 3x. I will then move all the variables to the left-hand side and all the constants to the right. So we have plus 3x, plus 3x. We have plus 1 on both sides. On the left-hand side, 3x plus 3x will leave us with 6x. The 1's cancel out, equals on the right-hand side, the 3x's cancel out, and I'm left with 1. We then divide both sides by 6, and this will leave me with a final solution of 1 over 6. Moving on to the next question, question number 9, we have the following. All right, now for this one, you have to think to yourself, okay, we do have that small base of 9, correct? But you ask yourself, 9 to the what power will give you 27, correct? And it's not possible, right? 9 to the first power will give you 9. 9 to the second power will give you 81. So you cannot deal with 9, okay? So you have to work with, let's say, 3, okay? 3 is a good one. 3 to the second power will give us 9. We write down the original exponents, x plus 5. We then have equals. On the right-hand side, we have 3 to the what power gives us 27. Well, that's going to be 3. Wrap that in parentheses. Write down the original exponent, x minus 1. We then distribute the exponent right here. We have 3 to the 2 times x gives us 2x. 2 times 5 gives us positive 10. Equals, we then have 3 to the power of what? 3 times x is 3x. 3 times negative 1 is negative 3. We then set the exponents equal to each other. 2x plus 10 is equal to 3x minus 3. We then move all the variables to the left-hand side, all the constants to the right. So we have minus 3x, minus 3x, minus 10, minus 10. And on the left-hand side, we have 2x minus 3x, which will leave us with negative 1x. The 10's cancel out, equals, on the right-hand side, the 3x's cancel out. I have negative 3 plus negative 10, which will leave me with negative 13. I will then divide both sides by negative 1. And this will leave me with a final solution of x equals 13. Let's go ahead and box that in. Moving on to the next question. Again, you ask yourself the same idea. We just saw these factors above. We saw 27 and 9, and we saw that the base should be 3, okay? So let's go ahead and try that out. So we have 3. Keep in mind that that's a fraction of 1 over 27. So the exponent should be what? Negative 3. Wrap that in parentheses. Write down the original, 4 minus x. We then have equals. We have 3 to the second power gives us 9. Wrap that in parentheses, write down the original, 2x minus 1. Then we simplify. So we have what? 3 to the power of what? Negative 3 times 4 gives us negative 12. Negative 3 times negative x will leave us with positive 3x. Equals, we then have 3 to the power of what? 2 times 2x will give us 4x. 2 times negative 1 will give us negative 2. We then set the exponents equal to each other. We have negative 12 plus 3x is equal to 4x minus 2. We then move all the variables to the left-hand side. and we move all the constants to the right-hand side. So plus 12, plus 12. Okay, on the left-hand side, the 12s cancel out. I'm left with 3x minus 4x, which gives me negative 1x, equals, on the right-hand side, the 4x's cancel out. I'm left with negative 2 plus 12, which will give me positive 10. I will then divide both sides by negative 1, and this will leave me with a final solution of x equals negative 10. Okay, moving on to the next question, we have the following. We can do the base of 3 for this one. So we have 3 to the 4x plus 1 equals 3 to the negative 3. Close parentheses, write down the original. We have negative 2x plus 1. We then simplify on the left-hand side. This remains the same. 3 to the power of 4x plus 1 is equal to 3 to the power of what? Negative 3 times negative 2x gives us positive 6x. Negative 3 times positive 1 will give us negative 3. We then set the exponents equal to each other. So we have 4x plus 1 equals 6x minus 3. We then move all the variables to the left-hand side, minus 6x, minus 6x. We move all the constants to the right, so minus 1, minus 1. And on the left-hand side, we have 4x minus 6x, which gives us negative 2x. The 1's cancel out, equals, on the right-hand side, the 6x's cancel out. I'm left with negative 3 plus negative 1, which will leave me with negative 4. Whoops. Negative 4. We then divide both sides by negative 2. And this will leave me with a final solution of x equals positive 2. Moving on to the next question, we have a base of 100. Now, keep in mind that you can also do the base of 10, okay? And let's go ahead and show the base of 10. I think that one would work out nicely. Well, no, let's try 100. That's fine. Okay, so we can do 100 right here because it's going to work out. 100 to the second power remains the same. On the right-hand side, we can rewrite 1 over 100 to be 100 to the power of negative 1. Wrap that in parentheses. And we write down the original exponents outside. Then we do what? We simplify. On the left-hand side, we have 100 to the second power is equal to 100 to the negative 1x. We then set the exponents equal to each other. 2 equals negative 1x. We then divide both sides by negative 1. And this will give us a final solution of x equals negative 2. Let's go ahead and box that in.